Hi there, and thank you so much for joining me. This video is going to continue our Module 10 series on conducting chi-square tests. So in my last two videos, I focused primarily on the one-way chi-square test. So in this video, or these next two videos actually, I'm going to talk about something called the two-way chi-square test. Okay. So, like I mentioned in my last series of videos, we use a one-way chi-square test when we know the population parameter, right? So just like with a one-sample t-test, we conduct these sorts of tests when we have access to some limited degree of knowledge about the population, right? So whether we know the population mean or the percentages observed in the population, then we can conduct a one sample t or a one-way chi-square respectively. But oftentimes we don't have access to the population, okay? And a lot of times, rather than just focusing on a single variable, whether it's a continuous variable or a categorical variable, researchers actually want to look at a potential relationship between multiple variables. So how do we do that? Well, with a two-way chi-square test, essentially what we're looking for is the degree of independence between two different variables, right? So essentially the question that we're asking with a two-way chi-square test is, are the observed frequencies or percentages in one group different from the observed frequencies or percentages in other groups? Okay, so we can use a one-way or a two-way chi-square test to look at the potential relationship between two variables, both of which are categorical. All right, so again, with the two-way chi-square, we are looking for a potential relationship between two different categorical variables. Or another way of saying that is we are looking to determine whether the percentages we observe in one group are different from the percentages we observe in another group. Okay, so let's look at a hypothetical example. So let's suppose we are interested in determining whether there's a potential relationship between extroversion and smoking, right? Well, both of those are categorical variables with two levels respectively. So for extroversion, we have both extroverts and introverts. And with smoking, obviously we have smokers and non-smokers, okay? So now that we've defined our variables and their respective levels, let's look at our sample. So let's suppose we collect data from 119 people and we find the following. Okay, so in our sample we have 38 introverts who are non-smokers, and 16 introverts who are smokers, and we have 24 extroverts who are non-smokers and 41 who are smokers. Okay, so now that we've looked at our data set, let's go ahead and define our null and alternative hypotheses, right? So in this case, the null hypothesis is going to assume that the percentages observed for both groups, for both introverts and extroverts, are going to be equal to each other, right? Or another way of saying that is that extroverts and introverts are equally likely to be smokers, okay? Whereas our alternative hypothesis is going to say that there is a difference in smoking behavior between introverts and extroverts, right? So again, the null hypothesis says that they're equally likely to be smokers, And the alternative hypothesis suggests that smoking behavior is going to differ in some way between introverts and extroverts. Okay, so we've already got the observed frequencies, okay, or the observed percentages from our sample, and we will use these observed frequencies to calculate the expected frequencies, okay? So just like we had observed frequencies and expected frequencies in the one-way chi-square, we're going to have the same values and in fact the same formula for the two-way chi-square. Okay? So now again we have the observed frequencies and we just have to calculate the expected frequencies. Okay? So in order to calculate the expected frequencies, first we need the row and column totals for the observed values. Okay, well that's easy enough. So our column totals are going to be 38 plus 24 for the non-smoker column and 16 plus 41 for the smoker column. Okay, so that gives us 62 and 57 respectively. And then our row totals are just going to be 38 plus 16 for the introverted row and 24 plus 41 for our extroverted row. Okay, and again, our total sample size is 119. Okay, so how do we use this information to calculate the expected frequencies? Okay, well, to get an expected value, we have to first multiply the row total by the column total and then divide that by the total sample size. Right? So what do I mean? Well, for extroverted smokers, to get the expected value or the expected frequency, okay, I would first go to my row total, right? So in the table that I just showed you guys, right, extroverts, the row total for extroverts is 65, and the column total for smokers is 57, okay? So I would multiply 65 times 57 and divide by my total sample size, which is 119, and that would give me 31.13 for my expected value. Okay, similarly for introverted non-smokers, right? So my row total for introverts is 54, and I would multiply that by my column total for non-smokers, which is 62. Okay, and divide that by my total sample size, which is again 119, okay, and I would get a value of 28.13, okay. So go ahead and calculate on your own all of the rest of the values in the table. So we have 2 more values to calculate. Okay, and then for introverted smokers, right, the row total for introverts is 54, and I would multiply that by the row total for smokers, and I would get 54 times 57 divided by 119 for a value of 25.87. And then for extroverted non-smokers, I would multiply my row total for extroverts, which is 65, times my column total for non-smokers, which is 62, and divide that by 119, and I would get 33.87. Okay, so now I've got all of my expected values, my observed and my expected values. So now I can use those values to calculate chi-square. Okay, but before we calculate chi-square, we should check that all of the assumptions of the chi-square test are satisfied. Okay, so the first kind of arbitrary rule is that the expected values in each cell, so each of our 4 cells, should be at least 5, okay, which they are. And also, most importantly, the categories should be mutually exclusive, right? So whenever we are calculating anything using categorical variables, we want to make sure that a given value only falls within one of our levels, right? So the same person can't fall into multiple categories, okay? And I think it's correct that we can assume if someone is a smoker, they can't simultaneously be a non-smoker, and they also can't simultaneously be both an introvert or an extrovert, at least provided that our test of extroversion is reliable and valid, right? So for now, we have satisfied all of our assumptions. Okay, so now we're going to use the same formula that we used in the one-way chi-square to calculate our chi-square value. Okay, so again, we're going to take, for each level of the category, right, we're going to take the observed minus the expected, square it, and divide it by the expected value, and add those all up for each of our categories, right? Okay, so we have our observed frequencies, which we got at the beginning of the problem, and we have our expected frequencies, which we've just calculated using the row and column totals. Okay, so we'll add a third column in our total where we subtract the expected value from the observed value, right? So 38 minus 28.13 is 9.87. 16 minus 25.87 is 9.87. 24 minus 33.87 is also 9.87. And 41 minus 31.13 is 9.87. Okay? But again, those values cancel out, just like they do for standard deviation, right? So we're going to square those differences. Okay, so just like we did with the one-way chi-square test, we're going to sum up our last column there, the observed minus expected squared over expected column. So if we do that, we have 3.46 plus 3.77 plus 2.88 plus 3.13, which gives us a grand total or a grand sum of 13.24. So 13.24 is our obtained chi-square value. Right? And if you've been paying attention, you would know what our next steps are, right? So now that we know that our chi-square value is 13.24, we need to set our alpha level to 0.05, and we need to calculate our degrees of freedom so that we can compare our obtained chi-square value of 13.24 to a critical value. Okay, so the calculation for degrees of freedom for the two-way chi-square is it's simple, but it's simple as long as you know the formula, right? So for two-way chi-square, your degrees of freedom is just going to be the number of rows in your table minus 1 times the number of columns minus 1. Okay, so by this I mean the table of your observed values, right? So in our table, we have 2 rows and 2 columns. So it's going to be 2 minus 1 times 2 minus 1. Okay, so 2 minus 1 times 2 minus 1 is equal to 1. Okay, so with a degree of freedom of 1 and a critical value and an alpha level of 0.05, then we know that our critical value is 3.84. Okay, and we're going to apply exactly the same decision rule. So if our obtained chi-square value is larger than our critical value, then we can conclude that there is a significant relationship between extroversion and smoking, and we can reject the null hypothesis, right? So 13.24 is certainly larger than 3.84, so we can feel comfortable rejecting the null hypothesis and assuming that there is a relationship between our variables. But we can actually include more information than to say that there's a relationship between extroversion and smoking by simply looking at our percentages, right? So again, because we're dealing with categorical variables, we're not going to report things like the mean and standard deviation that we would for continuous variables, but we can talk in terms of frequencies or percentages. And if we do that, if we compare percentages who smoke across whether you're an introvert or an extrovert, we see that extroverts are significantly more likely to smoke than introverts, right? So we see which group is more likely by looking at the percentage, and we assume the significance that one is significantly more likely to smoke than the other because our comparing the critical value and obtained chi-square value has led us to reject the null hypothesis and conclude that there's a significant difference between smoking behavior in extroverts and introverts. Okay, so how would we write this up in APA format? Okay, well, first, we're going to indicate our hypothesis, right? So we hypothesize that smoking behavior would differ between introverts and extroverts. And then we would talk about the particular type of test that we conducted. So we did a two-way chi-square test, and we found a significant relationship between extroversion and smoking. Okay, and then you're going to report your chi-square value of 13.24 and your degrees of freedom in parentheses of 1. Okay, and then you're going to indicate that your p-value is less than 0.05 such that 63.08% of extroverts in our sample were smokers, while only 29.63% of our sample of introverts were smokers. Okay, so again, it's all the same formula. If you have a hypothesis, you would state the hypothesis. Then you would indicate the type of test you conducted. Then you would report the results of that test in terms of your obtained statistic, in this case your obtained chi-square value, your degrees of freedom, and whether or not your p-value is less than or greater than 0.05, because that's going to indicate significance. And then finally you're going to report your percentages, right? So because we're dealing with categorical variables, we would report percentages, but if we were doing a different test and we were looking at continuous variables, we would report the mean and standard deviation. Okay. So you might be wondering where those percentages came from that I just quoted. So where did I get the 63.08 and the 29.63? Okay. Well, how do we get those percentages? If we look at our table, right, with our row totals and our column totals, we see that the total number of introverts is equal to 54. Right? And 16 of those 54 introverts are smokers, right? So if I divide 16 by 54, I get 29.62% of introverts are smokers, right? And similarly, if I look at the total number of extroverts, right, in green here, the total number of extroverts in our sample is 65, and 41% of and 41 of those 65 participants are smokers, right? So then I would just divide 41 by 65, and that would give me a percent of 63.07. Okay? All right, so just like I did for the one-way chi-square, I'm going to follow this video up with another example that we can work through together. And certainly if you have any questions, don't hesitate to contact me, and I look forward to seeing you guys in my next video.